Okay, now we want to turn our attention to identifying vertical and horizontal asymptotes. And basically it says here we're going to have a function where there are no factors in common, so we cannot factor and cancel. And it says if c is a 0 of q of x, that means the denominator. If c is a 0 of the denominator, then x equals c is a vertical asymptote of the function. As far as horizontal asymptotes go, what you do is you look at your function and you look at the degrees of the leading terms. Okay, so the x to the n in the numerator, x to the m in the denominator. If n is higher than m, in other words, if there's a higher degree in the numerator, then there's no horizontal asymptote at all. If the degree of the numerator is less than the degree of the denominator, then the line x equals 0, or the x-axis, is the horizontal asymptote. If the degree is the same, then you're going to have the ratio of these leading coefficients, y equals that ratio, as the horizontal asymptote of the graph that gets drawn. Before we start graphing these, let's start looking again at the domain and some of the notation involved. First off, we want to find the domain here. If we look at g of x, we will see that the numerator factors into the difference of two squares, and that the x minus 3's are going to cancel each other out, and we will have x plus 3. If we were looking just at the x plus 3, we would think that the domain is all real numbers. But we have to go back to the original function before the cancellation. Note that x is not equal to 3, and use that to write our domain. So the domain here is from negative infinity up to 3, united with the interval to the right of 3 from 3 to infinity. We are now being asked to analyze this graph a little bit, and the first thing we're asked, and I'm going to move this up just a little bit here, is as x approaches negative infinity. In other words, as we go to the left, what's happening to the y value? It's approaching negative 2. This next part, as x approaches negative 3 from the left, as we approach negative 3, what's happening to the y value? It's going up. It's kind of hard to see because I'm not showing you here, but it's going upward there. So answer, positive infinity. As we approach negative 3 from the left-hand side, the graph is going downward, so the answer is negative infinity. And as the function approaches positive infinity, as x approaches positive infinity, the y value is approaching the horizontal asymptote of y equals negative 2. Now, we want to look at where is the graph increasing or decreasing. Well, I'm looking at this, and it's increasing here. The whole left side of the graph, it's increasing. The whole right side of the graph, it's increasing. But it's not increasing on the vertical asymptote at negative 3. So the intervals on which it is increasing is from negative infinity to negative 3, union negative 3 to infinity. Now, it's never decreasing, as we saw from the function. Never decreasing. The domain would be all real numbers, but there's no graph at 0, or negative 3, anything, so we have to exclude negative 3 from the domain and list the domain out as negative infinity to negative 3, union 3 to infinity. The range, the y values that are assumed by the function. The graph goes up forever, it goes down forever. Here's our x-axis. It's y equals negative 2. That is never assumed as a y value. So we will have to exclude negative 2. The range is negative infinity to negative 2, union negative 2 to infinity. The vertical asymptote is that line x equals negative 3, and the horizontal asymptote is the line y equals negative 2. To determine the vertical asymptote of a function, we ask where is the denominator equal to 0. At x equals negative 7, we're going to have a vertical asymptote. In this second function, we can factor this denominator, it factors into 3x minus 1 times x plus 3. And so that tells us we're going to have vertical asymptotes at x equals 1/3 and at x is equal to -3. That's how we analyze the vertical asymptotes.